So these are the things that you should remember from trig. These identities, which are easy, right? So you've got to know these, right? You should know your unit circle. You're not going to have any timed trig quizzes. However, the longer it takes you to solve a trig unit circle problem, the less time you have to solve other things. Even odd you don't use that much, but sines are odd, cosine is even. So, not super important. These are important. Do you not know what even odd is? Even symmetric to the y-axis. Odd is symmetric to the origin. Right. These are important. You've got to know these Pythagorean identities.
Wait, which one was odd?
Cosine is even because it's symmetric to the y-axis, and sine and tangent are odd. And then you've got these double angles, half angles, and sum and difference. Now, these you will probably never see. These you will probably never see. These you see, maybe not tangent, but sine and cosine you see. Cosine you'll definitely see when we get to the polars unit. But not really right now. Half angle and sum and difference are not as important. Okay? So remember those, and then you should be good to go. On the back, I just put in the graphs of sine, cosine, tangent, secant, cosecant, and cotangent. And it has their domain and range and period and zeros listed. But knowing the general shape is really all you have to do. But that's just for reference. Okay, now let's go to the easy stuff. Okay, don't act so excited. The derivative of sine is cosine. The derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cosecant is negative cosecant oh, I forgot an x. Derivative of secant x is secant x tangent x. Derivative of cotangent x is negative cosecant squared. Okay? Just memorize them. Cosines, all the ones that start with C is a negative. So if you are taking the derivative of anything with a C, it's a negative. And then if you remember sine, tangent, and secant, then you should be able to easily get cosine, cotangent, and cosecant, right? Because it's just the opposite of what those initial three are. All right, let's go back to unit 1. How do I prove continuity? Good. Limits have to exist or go. And what else for it to be continuous? Because the limit existing is not enough.
The value has to exist.
Mm-hmm. So we have to have that f of 0. Now from the left-hand side, do I choose sine or tangent? Which one's on the left? Sine. Okay. So sine, we plug in 0. And that's 0. Cool. For the middle, for the right-hand side, I choose tangent. And tangent of 0 is 0. Good. And then I choose f of 0. I also choose tangent, because that's where it's equal, and tangent of 0 is 0. So check. Therefore, triple dot, continuous. Right? Yeah, but I don't care. It's not continuous at pi. You're right. It's not continuous at pi over 2 and to 3 pi over 2. But I only want to prove continuity only at 0. Okay. So you're right. This function has discontinuities in it, but I'm only proving continuity at the 1x value. Okay. Are we differentiable? How do we prove differentiability? Limits of the derivatives, right? Okay. So what's the derivative of sine? Uh-oh. And we plug in 0. What's the derivative of tangent? Secant squared. Plug in 0. Cosine of 0 is
1.
Secant squared of 0 is 1. Okay, cool. Therefore, differentiable. Nice. We've proved continuity and differentiability. You remember that? Yeah?
Yeah.
Yeah. Okay. I'm not a doctor. Okay, let's take the derivatives of these. So, normal derivatives, y equals sine x minus cosine x, y prime equals
Cosine x.
derivative of sine is cosine, and the derivative of cosine is negative sine. Cool. And then we're done. For
Wait, you got it?
oh, plus. For number 2, what do I have to do? Quotient rule.
Yay.
Okay, so what did you start with?
X plus 1 squared.
X plus 1. Oh, on the bottom. Derivative of tangent
Secant squared.
minus tangent x. Derivative of x plus 1 is just 1, so I won't write it. All over x plus 1 squared. Cool. Number 3. What is my y prime?
0.
Yes. Why?
Is it constant? Y is 1.
There's no x in here, so I can't take the derivative of, well, the derivative of a constant. This is root 2 over 2 is 0. Always, right? Yeah.
You know what? Y prime, y equals 3
On a free response, it's always good to show what you're working with, but I don't know. It depends on, yeah, just do it. Depends on how I'm feeling that day. 4, y prime. What, for this one, I must do product rule. X cubed, derivative of sine is cosine, plus 3x squared sine x, right? All right, you try 5, 6, 7, 8. Do it. Just do it. 8 doesn't look very good. Must redo it. Your answers might be different from mine if you didn't adjust 7 and 8.
Yeah, mine really
I just didn't feel like doing quotient rule. 7 is easier if you just make it x tangent x.
Mine really looks dirty.
Does yours look different? Dirty.
Why?
It's not dirty.
Lots of X.
Let me pull out what
You also forgot this one.
this was. You can compare it to that one and check if you didn't rewrite it. That's how it would look. Okay. Questions on 5 through 8? No, because when you raise this to the second power, it's 2 over 1. Yeah. So you do the top but not the bottom. Okay. 4 over 9 is if it was just 2/3 in the denominator. Okay. All good? Now let's do implicit, which is what we did before. So for implicit, we are doing the tangent and normal line to this. What do I need for a tangent and a normal line? Okay, I need the derivative. How do I get the derivative? Oh, okay. So 3y squared dy dx minus, good.
That's good, Andy.
2y times x dy dx minus y squared, right, plus derivative of cosine is
Negative sign.
oh yeah, xy times no product rule x dy dx plus y
It's like a matrix algebra.
equals 0, because this is inside of cosine. So you have to do product rule.
Eddie, stop. He's like smelling the orange peel and he's coughing.
Okay. What else do I need? To solve for dy dx here would be really annoying. What else do I need for tangent and normal line? This is the equation for slope. Okay. I can plug 0 in, right? But I don't know what y is. How do I find out what y is? 0 goes into the original. So we get y cubed minus 0 plus cosine of 0 equals 2. So y cubed plus 1 equals 2. Y equals 1, yeah. Okay, now we can plug in 0 and 1 in here. So if I plug 1 in, so I have 3 dy dx here. This is 0. Then I have minus 1. And then this is
0.
0, because sine of 0 is 0, so that whole thing cancels. So all I have is 3 dy dx minus 1 equals 0, and that's a lot easier to solve than to solve for dy dx here. So our slope is equal to 1/3, right?
Yep.
And then our tangent line is
Y minus
1/3 x, right? And my normal line is y minus 1 equals negative 3x. Yeah. Okay. One special thing that you should know when you're taking derivatives and integrals of trigs. Let's say I have, I want you to take the derivative of sine squared x. How do I take the derivative of sine squared x?
Oh, you have to do that product rule for
Right, because sine squared x is really
sine x
sine x times
times sine x.
sine x, or sine x all squared, right? So to take the derivative of that, then you'll see that equals, the derivative of the outside is 2 sine x, right, to the first times cosine x.
Yeah. So if you did product rule, would that work too?
You could do product rule and that would work too. And then if you're on multiple choice, it would be really tricky, and they would say that this is sine of 2x, because that's the identity for double angle. Yeah. Man.
So can we just like figure out that sine will work too?
No, you can't just put this 2 here. It doesn't work all the time like that. Okay? So just be careful. Alright, derivatives are not that bad.
Circle.
Integrals get a little bit trickier. So, integrals basically just work backwards from derivatives. So if you have the integral of cosine, then it's sine. The integral of sine is negative cosine. The integral of secant squared is tangent. The integral of secant tangent is secant. Cosecant squared is negative cotangent. Cosecant cotangent is negative cosecant. Most of the c's stay the same. Like the integral of anything with a c ends up being negative. Yeah, because it was negative on the original, but it's not on this one. The only one that's a little tricky is the derivative of sine. Or sorry, the integral of cosine is positive sine, and the integral of sine is negative cosine. So if you have problems remembering that, then a trick is to write these things in order on your test, or maybe just s's and c's, and you can go sc, negative x, negative s, negative c, s, so that if you want to take the derivative, it's just the next one down, and if you want to integrate, it's the next one up. So it helps you keep the pluses and minuses correct. Okay, but if you don't need it, then you don't need to write it. All right, let's talk about these. So the integral of 2 cosine x, the 2 is a coefficient, so we can just take that out. And the integral of cosine is just regular sine. Yeah, that's the tricky part. So this is just 2 sine x plus c. Right. Okay. For number 2, sine of 4x. 4x is inside the sine. So, guys.
Is this sine squared to 2x?
What?
Sine squared to 2x.
No.
I don't know. I just like
What
putting
tells
that
you if it's not just sine of 4 times x versus sine of 4x?
Sine of 4 times x would, like 4x is together, and then it's just sine of the quantity 4x.
Would they like trick you and put a question that's like sine of 4 times x instead of
That's like
If they did that, then it would be sine of 4 with parentheses around sine 4. Yeah.
So it's assumed.
Yeah. Okay. U equals 4x du equals 4 dx. So what should I have the dx here, but I've got this 4. So 1/4 on the outside, integral sine of u du. And then the integral of sine is negative cosine, so negative 1/4 cosine. We go back to 4x and then plus c. Now, that's a lot of work. If you can do this in your head, I would advise you to go from here to here, just without writing all of this extra stuff. Do you know what I mean?
so use your head.
Let's do number 3 together. So the 1/2 x is here. So if u was 1/2 x, don't write it down. If u
So
was
2
1/2 x,
sine
what would
1/2
du be?
2 sine
1/2. So what would I have to bring out in front? A 2, and then integrate cosine, which is
sine.
sine of 1/2 x, and then plus c. Do you see what I'm saying? So try to do it without doing all the u sub stuff, but if you need to, go ahead. But it's best if you don't have to. Like if I made u x plus pi over 4, what's du? Just 1, right? So do I have to bring anything out?
No.
No. So then what's the integral of sine?
Negative
Negative cosine, and then you can leave that stuff in. But if you need to do, remember, if you need to do all of these steps, then you can do all those steps. It's just easier if you don't have to. Okay. Again, 5, 6, 7, 8 is for you. If you've got to write the u's out, then write the u's out. If you don't have to, that's better.
Let's see.
Okay, let's see if you got it without having to write all the stuff out. Did you mess up your pluses and minuses?
Yeah.
Yeah, that's the trickiest part. Is like, and especially when you're going to be doing derivatives and integrals like within the same problem, then it's hard to remember which one is which. That's why it is helpful to write this and you just go straight down or straight back up. Okay. Anybody have any questions on 5 through 8?
So what's gonna be the thing?
What?
Halloween theme.
I don't know. I do know, but I'm not telling you.
Oh.
Okay. 9. This one's not too bad. What do I do here?
Pick up 5.
Okay, 5. And then what's the integral of secant squared? Oh, and I have a 2x inside, so
Tangent.
what should I do with that 2x though?
So 5 over 2 tangent to x.
Yeah, u is 2, so du is 2. Sorry, du is 2, so we have to divide by 2. Integral of secant squared is
Tangent.
tangent. 2x goes back in, and then add your c. Okay, 10. I don't have an integral for a sine squared. I only have it for secant and cosecant. Yeah.
Is it sine -2x? If you brought it up.
Yeah. If you brought it up, it would be 4 sine to the negative 2x. Or yeah. 1 over sine squared is the same thing as saying cosecant. Right? So use those properties, trig properties. So the integral of cosecant squared is cotangent negative plus c, right? Okay. And 11 can I rewrite as well?
Yeah.
So this would be integral of secant squared 4x plus 1
Tangent.
dx. So
Or
my
would it be cotangent squared?
No, go forward.
oh, not squared, sorry. Thank you. Just cotangent. 1/4 tangent 4x plus 1 plus c. Okay. 12. Now we've got definite integrals. So what's the integral of cosine? Just positive sine, right? And we're going from 0 to pi over 2. So sine of pi over 2 minus sine of 0. So it's 1 minus 0, which is 1. Now 13, if you do the u sub in your head and you go back to x, you don't have to change your bounds. But if you write your u sub down, you've got to change the bounds. So integrate sine 2x for me without using u sub, or kind of doing u sub in your head. What would it be?
Negative 1/2
cosine. And it's negative because the integral of sine is negative cosine. Then we can go back to 2x and then go from 0 to pi over 6. But you can only keep the same bounds if you don't write your equation in terms of u. So cosine of
So you just do the implicit.
you mean u sub?
Well, yeah.
Yeah, you do the u sub in your head. So we have negative 1/2 cosine of pi over 3 plus 1/2 cosine of 0. If there was free response, you could stop here, because anything that you can put in a scientific calculator, you can stop at. But if you can't immediately type it into a scientific calculator, then you've got to keep going. Let's just keep going because multiple choice won't give you the answer like this. So cosine of pi over 3 is 1/2. So this is negative 1/4. And cosine of 0 is 1, so plus 1/2. And so that's 1/4 is the answer. Okay, 14. Tangent squared, I do not have the integral of. It's not on my list of things I have
Not
the
on my
integral
list.
of. So, you don't know product rule for integrals yet. You will later, though. I will wait for you to think of an idea.
Sine square over cosine square.
Scientific notation.
That doesn't really work. Eric.
We turned into we turned into cosecant squared over secant squared.
Yes, we could, but I don't think that would help at all. Because then I would have like a fraction and u sub within it. Hanwen? Yes. You can do a Pythagorean identity. Tangent squared is equal to
Sine plus.
secant squared minus 1, right?
Oh my god.
Yeah. So secant squared of 1/2 minus 1. All right, now if we were to integrate, remember this 2 does not apply to, like when you do the du and you divide, it doesn't apply to the 1 because you're not doing u sub with the 1, you're only doing it with the secant squared part. So this part would, what's the integral of just that part? 2 tangent 1/2 x. What's the integral of 1? Yeah, just x. Okay, don't put the 2 with the x because that doesn't distribute. And then this goes from pi over 3 to pi over 2. And then you plug in pi over 2, and then you plug in pi over 3. But to save us some time, we're not going to do it. We integrated just fine. Okay, 15 and 16 will do. We'll skip 17, and then you're going to do 18, 19, and 20. Ideas for 15. There's actually 2 ways to do it, so I'm going to put this on here.
One of the identities.
Somebody wants to use an identity. Okay, but it doesn't have, like, I can only use the identity if it's, like, the sine of 2 theta is equal to 2 sine theta cosine theta, which I almost have. I have cosine and sine, but I'm missing this 2. Can I just put it in? You're kind of on the right track, John. What you do is you put it in. But then you take it out. So here I put the 2 in, but then I'm going to multiply by 1/2 to get rid of it. So it's like, yeah, so you did it, but you like undo it. Now what does this simplify to? Yes, sine of 4x, because it's double angle. So whatever angle you have in here gets doubled. So instead of sine 2x, you get sine 4x. Our bounds are still 0 to pi over 4. Okay, now I can integrate. So what's the integral of sine of 4x? That would be 1/4. So now I have 1/8 on the outside. Negative cosine of 4x from 0 to pi over 4. And then that gives us negative 1/8 times negative 1 plus 1/8. Or 1/4. That's one way. Here's the other way. You let, what? What do you want?
No.
You let u equal sine of 2x because du is 2 cosine 2x dx, right? And then this cosine 2x dx can be canceled with that one. So now you're just left with that 2. So then you pull out a 1/2 integral of u du because sine 2x is u. And then I can change my bounds. If I plug 0 in, then I get 0. And if I plug in pi over 4, sine of 2 times pi over 4 is 1. Right?
Yeah.
0, 1. Integrate u is u squared over 2. So then I get 1/4 minus 0, or 1/4 is the same thing.
Wow.
I like
Which way do you like better?
First one.
doubling.
Double angle?
Second one, I don't
I feel like you could really screw up depending on the use.
Well, maybe. Okay, let's try 16. There's 2 ways to do this one as well. What's the first? Give me a way.
Tangent and
Okay, u equals sine x. We can only sine theta. Well, I can't do sine squared because the derivative of that wouldn't be there. But the derivative of sine is there. So du is cosine x, or cosine theta, d theta. That cancels completely with that one. So really I just have integral of 1 over u squared du. And what's the integral of 1 over u squared?
Negative u to the negative.
Yeah, negative u to the negative 1, or negative 1 over u. And then we go back to x, or go back to theta. So negative 1 over sine theta plus c. Okay, or the other way is to rewrite this as the integral of cosine theta over sine theta times 1 over sine theta. You know, using those trig identities that you know. And then that is equal to cotangent theta cosecant theta. And what's the integral of cotangent cosecant?
Wait, but isn't it sine squared? No.
Right, but I divided into 2
negative
sides.
cosecant.
Negative cosecant theta plus c, which is this and this are the same.
Oh, I
In
like
that-
the second one.
It's the same. Yeah. So there's more than one way to skin a cat. What?
I still don't understand why people use that thing.
Well, I don't know. Maybe somebody was like, I only know this one way to skin a cat, and then the other person was like, oh no, there's more than one way.
I think that's definitely what happened.
That's exactly the story.
No, exactly. You should go tell that.
Documented in
Why
history.
do you keep calling for doctor?
Have you ever seen that show,
Your neutral term.
Drunk History?
Doctor.
It's on like the History Channel or something, but they get like these people inebriated and they retell like stories that happen in history, but then they have like actors recreate this, recreate the like scene that they explain,
Oh my gosh.
and they're like, as the guy's like narrating, they like do like lip sync or whatever.
That's
Okay.
actually hilarious.
Yeah, it's really funny. So your job is to do 18, 19, and 20. And once you finish, then you can grab your test.
Oh, I already have my test.
x sine of x squared?
Wait, are we doing 7?
Yeah, so
Oh, well, that's not nice.
you make u x squared because du is on the outside. You're always looking for something where the derivative is outside of it. Okay. And please check your answers to this after you've finished.
Yeah, I got it.
I put it up there.